Now see a production of amplitude modulated wave. There are many ways to produce amplitude modulated wave, but let us discuss one method here, where we can take, suppose this one signal is here, where we have taken modulating signal. These two are added at this point and there are the carrier wave signal. Then after addition, these signals are passed through a device here that is called square law device. Here whatever the equation you obtain after adding these two carrier and modulating signal, that is solved actually according to the non-linear device that is called a square law device according to this given equation. Then this is passed through the band pass filter. Here is a band pass filter. Here it filters out unnecessarily frequencies which are not required, and then ultimately we get here AM wave. So this is about the production of the amplitude modulated wave. Now let us discuss mathematical part of this. So in mathematical part, this was the block diagram of the simple modulator. Now let us see mathematical part of the production of amplitude modulated wave. Suppose you have got equation for the carrier wave at any time, that is AC sin omega ct, and mt, that is here mt am sin omega mt. Now when you add these two, you will be getting here xt is equal to AC sin omega ct plus am sin omega mt. Now square law device solves according to the relation y is equal to ax t plus bx square here t, according to this function where a is constant over here, a and b are constant. So square law device solves this relation according to this. So now if you put everything in this one, you will be getting y is equal to here a xt value of xt, that is here AC sin omega ct plus am sin omega mt plus here we can get b AC sin omega ct plus am sin omega mt whole square. So we can simplify these relations here. So when we simplify these relations, we will be getting y is equal to AAC sin omega ct plus AAM, where A, capital A is constant here, AAM sin omega mt plus this we can break. So we will be getting B AC square sin square omega ct plus BAM square sin square omega mt plus twice of B AC AM sin omega mt and sin omega ct. We have got this. Now we can simply, this I have taken actually the part of this, I have broken this equation according to a plus b whole square. Now we can use trigonometric relations here. So in trigonometric relations, these parts can be actually simplified, this, this and this. When we simplify these parts, we will be getting y is equal to AAC sin omega ct plus AAM sin omega mt plus this we can solve here sin square omega ct, that is sin square theta 1 minus cos 2 theta upon 2. So that will become plus BAC square by 2 minus BAC square by 2 cos twice of omega ct. This is for this now. Similarly, for this we can solve BAM square by 2 minus BAM square by 2, and here we can write cos twice of omega mt plus this is left behind now, this part. So we can write here BAC AM divided by 2, the 2 that will get cancelled. So, only we can write here now this one BACAM, it is here can be written cos omega c minus omega m into T minus cos omega c plus omega m into T. Now, see here in this equation, now we have got so many frequencies, 1 omega c, omega m, twice of omega c, twice of omega m, and here omega c minus omega m and omega c plus omega m. But now if you take this and this, these are the DC part, DC component of the equation, rest are the variable that is according to the sine function. So, all these frequencies are obtained, but you know for the AM wave, for the spectrum we need only upper sideband, lower sideband and the frequency carrier wave. So, we need only omega c minus omega m and omega c plus omega m. All these frequencies are required, rest all the frequencies, unwanted frequencies are filtered out. So, here in the block diagram we have seen there is a band pass filter which filters out all these frequencies which are not required, only these frequencies are here. So, these frequencies come out and we get AM wave which is actually the function of the sine. Now, see here we have seen the amplitude modulated wave and its production, and now the frequencies also we have seen. So, now when we get amplitude modulated wave, this has to be transmitted. So, actually the block diagram for the transmitter is, first we take here amplitude modulator, So, from here we get CT, from this side we get MT, and then there is a power amplifier, and then there is antenna, transmitting antenna. So, this we can take as a block diagram of the transmitting antenna here. So, amplitude modulated wave first produced by using the simple modulator, and after that the signals are amplified and then they are transmitted. After transmission there is a now receiving part. So, there should be also the receiving part. So, in receiving part what happens? There is antenna which is called receiving antenna, there is amplifier. So, receiving antenna first receives signals and signals are amplified. Then there you will be getting here IF stage, intermediate frequency stage. Then you will be getting here detector which detects the signal actually, and then again you will be getting here, we can write here in this case, we can take the next part that is here amplifier, and we get ultimately here the original signal. So, this is about the block diagram of the receiving antenna. Now, see here the block diagram of detector. First one, see here the AM wave, that is this is the AM wave which has been transmitted by transmitting antenna. This wave comes to the rectifier. Rectifier is a device which converts AC signal into DC signals. So, this is passes through the rectifier. As it comes out of this rectifier, the signals are like this, only one unidirectional, one sided. So, we can say this is here the direct signals here. Now, there is an envelope detector, this signal goes to here, it detects envelope detectors is here, and then here this is the finally we get output. So, here actually the separation of the the low frequency signal from a high frequency signal takes place. So, this process also referred as demodulation. So, at the detector part demodulation also takes place. So, now in this part you have to do the block diagram of the detectors, block diagram of transmitting antenna, block diagram of receiving antenna. Now, let us do some questions based on all these concepts.